Hello, can you hear me? Hello, can you hear me? Can you guys hear me?
Yes, sir.
Okay. So, hello everyone. I am Imanshu Mishra and I am a PhD scholar in Plant Mechanics Department in IIT Madras. Basically, I am working in geophysical flows, particle-led in geophysical flows. So here, I will take the tutorial for the course Engineering Mechanics that has been offered in NPTEL. So for this semester, I will be taking tutorial class every Saturday this time from 3 p.m. to 5 p.m. for 12 weeks. So usually I at the beginning of the class I revise the topics that has been discussed in the NPTEL videos. So basically I revisit those topics in very brief manner, and so usually I introduce the topics, or should be said that briefly discuss the topic before solving the questions, and then I solve the question. I usually take one or two topics each weeks, and then related to those one or two topics, I solve around 8 or 9 questions after the brief revising or revisiting the topics. So today we will be starting with the resultant force. Basically, we will solve questions related to the finding of how to find the force resultant in the horizontal and vertical direction, how to take the components of the forces, and then how to calculate the movements, um, what is the sign convention while calculating the various movements, and then using the Wagner theorems and so on. So today, in today's tutorial, we will be primarily focused on solving non-equilibrium problems. But before discussing those problems, let's briefly revise whatever we have seen in the NPTEL videos. It's a very brief revision of the concepts, because these concepts we will be using in solving the problems. So we can begin by forces, or the type of forces. So you can actually classify forces on the basis of several process or parameters. Like, the force can be classified into external and internal forces. So basically, external forces means if you have any arbitrary body, then if you apply the forces from the outside, that is from the system that is not associated uh, with the body, then these forces are the external forces. Now, what happens? Let's assume that your body is not a rigid body, it's a deformable body. It can actually bend or responds to the forces. When it responds to the forces, it changes shape. Let's say this is the changed body. Now this change in the shape occurs when there is an internal forces which are acting. So let's say these blue color arrows indicates my internal forces. So internal forces are responsible for change the shape of the body. It can deform the body. But let's say if you assume your body to be a rigid and cannot deform, then the summation of all those internal forces are zero, and you need to concern about only external forces. Then you can actually classify the forces on the basis of the area or volume on which it is acting. For example, let's say I have a block here, and you place another block on the top of it. So if you magnify this area, you can see there is a surface area of two blocks which are in contact with each other. So basically the friction force is acting between the two surfaces, and this can be classified as contact force. So the pressure force, friction force, all these are the example of the contact force. Then there is something called body force. So body forces actually acts on the volume of the body. For example, let's say you have an object and it is experiencing the weight, which means it is under the influence of the gravity. So this gravity can act upon the volume of this body. So whole volume will be affected by the gravity force. And the other example of these body forces are electric and magnetic forces. So these are the type of forces. Now what happens, let's say you consider the external force which is acting on the body. Let's say this is the force P which is acting on the body. Then if you assume that if the body cannot deform, if the body is rigid, then you can actually draw a line of action. So basically if you slide this force, let's say I slide this force to this point or this point. So wherever you slide this force, unless it is remains inside the body, the response of the body to this force will remain same, which means you consider the body and this is a line of force. You apply this force P here, or you apply this force P here, or here, or here, or here, anywhere along this line of the body will react in the same way. So basically if you apply this force anywhere in the line of action, the body will react in the same way. So this is the line of action for the forces. Now let's consider you have a same body and now you have a two forces. This is P1 and let's say this is P2, and now you can draw the line of action for each force. So this is a line of action for P1 and this is the line of action for P2. Now you can see this line of actions of both the forces are meeting at one point A, which means that force P1 and P2 are concurrent at point A. So these are the concurrent force at point A, and their resultant can be defined as R. So this is the resultant force. Now, in order to describe the force in the body, we actually need any coordinate system. So you can have any coordinate system like spherical, basically a curvilinear coordinate system, or you can have a Cartesian coordinate system. So the first objective is to define the coordinate system. So once we define the coordinate system, we can actually study the various kinds of forces which are acting on the body. So in order to evaluate the force on the body, let's consider a, let's consider the Cartesian coordinate system. Now one of the reason that considering the coordinate system is almost compulsory because forces are the vector quantity. So actually you need to define the force in not only with its magnitude, but you also need to define the direction of each forces. For example, here we define the direction P1 in the vertical direction, and here we define the direction of P2 in the horizontal direction. So Cartesian coordinate or any coordinate system actually allows you to define the magnitude as well as the direction. So for this reason, your first step is always to define the coordinate system. So for simplicity, we will be mostly working with the Cartesian coordinate. So this is my Cartesian coordinate, 2D, two-dimensional Cartesian coordinate. So my horizontal axis will be x and my vertical axis will be y. And let's consider there is a force Fx which is acting along x direction and force Fy which is acting along the vertical direction. So force Fx in the horizontal and force Fy in the vertical direction. Then there is a resultant force which is acting. Let's say this is my R, which is a resultant force acting, and it is acting at an angle theta. Then, having known the resultant force, we can actually find Fx and Fy. So basically, you need to take the component of Fx and Fy, and to take the components, first you need to define the coordinate axis. So in the Cartesian coordinate system, my Fx will be given as f cos theta and Fy will be given as f sin theta, and you can even find your theta by using tan inverse Fy divided by Fx. So in the case if you know the component of the forces Fx and Fy, you can even uh, find the angle theta. Then just to write down the equation that we will be using to solve the problem, this resultant can be given as, sorry, Fx plus Fy. So resultant of the force in this Cartesian two-dimensional plane can be given by the summation of force Fx and Fy. So this symbol actually represents that all these forces are the vector quantities. So now let's say you have a two forces which are acting on the Cartesian coordinate. Two resultant forces. Let's say consider two different type of forces. So this is F1 and this is F2. This is Y, this is X. So you have given two forces F1 and F2, and then you can actually find the component of F1 along X and Y direction, and similarly you can do this for F2. So for this you can see the X component of F1 will be this, and this is the Y component of F1. Similarly, the X component of F2X will be this, and this will be the F2Y. So the result, so this F1 and F2 are the resultant forces. This can be actually written by F1 equals F1x, F1y, and F2 equals F2x plus F2y. So in order to, so basically we will be mostly denoting the resultant forces by R. So just not to create the confusion, it will be R1 and R2. So from this analysis, we can actually estimate that my resultant forces can be given by resultant forces in the x direction. Yeah, Shailesh, yeah.
Uh, Resultant force is equal to under root of fx square plus fy square, na sir?
Yes, yes. So It will be equal to fx square plus fy square according to the parallelogram rule.
Sir, according to parallelogram law, it is under root of fx square plus fy square plus 2 fxxy cos theta.
Yes,
I
yes.
think so.
Yeah, yeah, yeah. But in two-dimensional Cartesian coordinate, you can actually write in this form.
So you mentioned that r is equal to fx plus fy.
Uh,
Is it true?
no, 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 sorry. So this is not true. So this is just a summation of, let me check. No, no, no. So this is not a true quantity actually. So let me just revise this. So this is F1, this is F2, and this is R. So here the resultant will be F1 plus F2. This is F2x. Mm,
This is by triangle law, na? Yes, sir.
yeah, yeah, this is the triangle law. But
Okay.
here the resultant R can be defined by the summation of this F1 and F2. So basically here what you can do, this you can expand as F1x plus F1y I cap j cap plus F2x I cap F2y j cap. Then this will be Rx I cap and Ry j cap. So basically if you sum this and j cap together, you will have Rx and Ry. So this is R equals Rx and Ry. So from this analysis, you can say that the resultant force in the x direction will be the summation of all the forces in the x direction, and resultant force in the y direction will be the summation of all the forces in the y direction, because here you are summing f1x and f2x to get rx, and here you are summing f1y and f2y to get ry. So this is actually f1x plus f2x, and this is f1y plus f2y. So yeah,
It means you are saying vector summation of resultant, na sir?
yeah, yeah.
It is not magnitude. So magnitude will
No, no,
be
no, no, no. It's not a
effect
magnitude. The magnitude will be given by the fx square plus fy square. That can be given by that expression, but this is not the magnitude. This is the vector quantity.
vector quantity. Yes. Thank you, sir.
Yeah. So from this analysis, we can actually see that the resultant force in any given component will be the summation of all the forces acting on the body in that direction. Uh, and this can be clear from this two expression. So basically in all the questions where we have to find the resultant, we will be using these two expression. And in order to calculate the magnitude, we will be using the expression which is rx square plus ry square under whole root. So basically, there are three things to know. First thing is to find the component of the forces, given that you have already defined the Cartesian coordinate, and then you need to find the component of each forces along each coordinate direction. That is can be given by simple trigonometric rule. Then, in order to calculate the resultant forces at each of the component, you have to sum uh, all component of the force in that direction, which can be given by Rx and Ry, which is the summation of Fx and Fy respectively. And the third point is, in order to find the magnitude, you have to use this expression. So basically, whatever the question we will be solving today, we will be using this three concept. So let's start with the first question. So in this question, we have actually given three external forces F1, F2 and F3, and we need to calculate the component of F1, F2 and F3 along X and Y direction. So if we assume the Cartesian coordinate system X and Y, we need to calculate F1x, F1y, F2x, F2y, F3x and F3y. Now for each of these forces, you can see that even though the basic principles remain same to calculate the component of forces by using trigonometric relation, you can see for the first force, it is actually given uh, at a direction of 35 degree from the horizontal. For the force F2, they have actually given the triangle, which and they have represent the ratio of each side of the triangle. And for the FE, they have not given anything. They just given some random direction, and we need to calculate its component. So these are the three different cases that we will look to calculate the component of each forces. So for F1, we just have discussed how to calculate the component. So we have given the angle 35 from the horizontal. So it is pretty much clear that if I write F1x, so here just to draw in the Cartesian coordinate system, this will be my F1x and this will be my F1y, and I need to calculate these forces. So it is pretty much straightforward. So my F1x will be F cos theta, right? And theta is 35 here. So it will be, and F is 600 Newton. So it will be 600 cos 35. So I will get 491 Newton. And similarly, we can actually calculate F1y. Given an angle of theta, which is 35 degree, so my F1y will be F sine theta equals 600 sine 35. So it will be 344 Newton. So this is pretty much straightforward. We have calculated the component of F1, which is F1x along x-axis and F1y which along y-axis. Now let's calculate the component of F2. So you can see the direction of F2 is along minus x-axis and positive y-axis, right? Because if I consider my coordinate system like this is my x, this is minus x, this is y, and this is my minus y. You can see it is pointing in minus x direction and positive y direction. So my component of f2x or component of f2 in the x direction will be given as this. This is my f2x and this will be my f2y. Now instead of angles, here in this question we have given the triangle and the ratio of the triangle. So we have given this side as 3, this side as 4. Then using Pythagoras theorem, we can actually calculate this side, which will be 5. So basically, I have used 4 square plus 3 square under root, and it will give me 5. Now I can calculate the component using this triangle. So to calculate this f2x, so basically I am using the trigonometric principle. So in the earlier case, I have directly used the concept of angle, which is, let's say, cos theta equals f1x divided by f. So in earlier question, I directly use this angle, but now I am actually using this ratio f1x to f. So to calculate the f2x, I have to use the cos ratio, which is 4, this part 4, and this 5 because I already know that at this side what is my force. At this side, at side 5, my force is f2, but at side 4 I have to calculate. So basically I'm using cosine rule here. So my f2x will be minus 500 4 by 5. This is the cosine rule I am using here, right? Because cos theta will be 4 by 5 right here. So if you represent a triangle, you have a side 4 and 5, and this is theta, then this cos theta will be 4 by 5, and sin theta will be 3 by 5. So using the same cosine rule, I will get f2x minus 400 Newton. Minus because this is in minus x direction. Similarly, to calculate the f2y, which is in this 3 direction, I have to use sine rule, and sine theta will be 3 by 5. So f2y will be 500 multiply 3 by 5. So it will be 300 Newton. And it is positive, it is in the positive y direction, right? So in both of the cases, earlier we directly use of angles, but now we actually use the cosine and sine ratios to calculate the component of force. Now we need to calculate the component of force F3 here. So we can again imagine the coordinate system, right? And you can inspect the direction of each component. So in the y direction, you can inspect. So this F3 is in the downside direction, minus y direction. So if it is positive y, this is my minus y, this is my minus x, and this is my positive x. Then you can see the component of F3 in the y direction is in downward direction. So this is my F3y, which is along minus y, right? And you can see it is actually moving from left to right direction. This F3, it is actually moving in the right direction, right? So the component of x is F3x, which is along positive x axis. And now we need to first calculate the angles, because in this case we have not given the angle and we have not given any triangle here, so that we can use the cosine and sine ratio to calculate the component. So in this case we need to calculate the angle. Let's say, so this is my axis, so let's say this is my angle alpha. Okay, you can also assume any angle alpha here. So basically you can assume alpha from the horizontal direction, or you can assume some angle from the vertical direction. In this case, let's say I assume one angle alpha from the vertical direction f3y. So this is my angle alpha here. Okay, so you can see that this distance here, this distance is 0.4 meter. So now our objective is to calculate this angle first. Once we calculate this angle alpha, then we can calculate the component. So for this we have this triangle, and this is this triangle we have, and we know this length. We know this length, and we also know this length, right? So you can see this is 0.2 meter, and this overall length is 0.4 meter. So this will be 0.2, and this length is 0.4 meter, right? So you can write tan alpha equals to zero point 0.2 by 0.4. So it will be alpha alpha equals tan inverse 0.2 by 0.4. So when you calculate this, you will get alpha 26.6 degrees. So this alpha will be this alpha will come out to be 26.6 degree. Now you get the angle here, like in the first part of this problem you had 35. This part you calculate the angle. Now once you calculate the angle, it is pretty much easy to calculate the component. Then we can use these formulas to calculate the components. So here just notice that this angle is from the vertical direction, right? So to calculate f3y, and we have already given this f3 which is 800, so my f3y will be f cos alpha, right? And my f3x, which is in this direction or in this direction, f3x, it will be f3 sine alpha. And this should be a negative quantity because f3y is actually pointing in minus y axis. So my f3y will be minus 800 cos 26.6. So f3y will be minus 715.32 Newton, and f3x is 800 sine 26.6. So this will come out to be 358.2 Newton. So just to recap here, in this question we have given three forces, F1, F2 and F3, and we need to calculate the component of these three forces. And for all these forces we have given different piece of information. For example, for force F1 we have given angle, for force F2 we have given the sides of triangle, and for force F3 we have not given anything. So in the case we have given the angle, we directly use this trigonometric relation. We actually use of these angles to calculate the component of forces. When we have given this triangle, we actually use the ratio of these trigonometric identities to calculate the component of forces. And when we have not given anything, first we calculate the angle from the ratio of sides of the triangle. Once we got the angle, so we got the angle 26.6. Once we got the angle, we actually calculate the component of these forces by using these relations. And you can, so in this problem we actually define the angle from the vertical axis, but you can also define the angle, let's say beta, from the horizontal axis, and you can actually calculate beta from the sides of the triangle. And then from the beta you can calculate f3x and f3y. So for the beta case, your you can see you are making an angle from the x-axis. So for the beta case, your f3x will be f3 cos beta, and your f3y will be f3 sin beta, right? So any doubt in this question? So this is pretty much straightforward problem, just to take a grasp how to calculate the component of forces by using different methodology. So any doubt? If not, then we can move to the next problem. So in this problem we have given the magnitude of the resultant force acting on the bracket is to be 450 Newton, directed along positive u axis. Determine the magnitude of F1 and its direction phi. So basically in this problem we have given three different kind of forces, and it is being said that the magnitude of the resultant force is 450 Newton along this axis u, let's say it's r, and its magnitude is 450 Newton. And we have given different forces like F2, F3 and F1. And F1 we need to find the angle phi and the magnitude of force F1. So what we have learned until now, that the resultant force in the x direction is the summation of all the forces in the x direction. Similarly, the resultant force in the y direction is the summation of all the forces in the y direction. So in order to calculate Rx, Ry, or we need to define all the forces in the x direction as well as in the y direction. So let's consider force F1 here. So what is the x component for the force F1? So we have given angle phi here. So for force F1, its x component will be F1 sin phi. Because we have given the angle, so we can directly use of the angle to write the component of the force that we just saw in the last question. Similarly, for force F2, its x component can be given by directly 200 Newton. So you can see the F2 forces is already along the x-axis. So it's F2x will be equal to F2, which is 200 Newton. There will be no F2y because all the entire force is along the x-axis. So F2y will be 0 and F2x is 200 Newton. And for the force F3 we have given the triangle and its sides. So we can use of the sides to calculate the component of F3. So this will be my direction of F3x, and this will be my direction of F3y. And we already know, since we have solved last question, we know that how to calculate the F3x. So it will be 260 5 by 13. It's a cosine ratio. So on calculating this you will get 100 Newton, right? And it is said in the question that the magnitude of the resultant force is 450 along positive u axis. So this is my R, which is the resultant force. This is my R, which is the resultant force. It's along u axis, right? So what will be my Rx? What is the component of resultant force in the x direction? So this will be my Rx, and this will be my Ry, right? And we have already given an angle 30 degree. So R is acting along 30 degree from the horizontal axis. So my Rx is 450, which is my R cos 30. So basically it will be cos 30 multiplied by 50. So it will come out to be 389.7 Newton. So we are actually collecting all x component of forces. So we have collected all the x component of forces. Now we will collect all the y component of force, right? So my F1y will be F1 cos phi, right? Because the angle is taken from the vertical axis, so it will the vertical component will be F1 cos phi. F2y will be 0 because entire F2 is along the x-axis, which means there is no component of force in the y direction. So F2y is 0. F3y will be given as 260 12 by 13. So it will be, on calculating this, you will get 240 Newton. And Ry will be, because the component can be solved by directly using this angle 30. So it will be 450 sine 30. Sine 30 is half, so it will be 225 Newton. So this is my x component and this is my y component. And then we can use this fact that Rx can be given by summation of Fx and Ry can be given by summation of Fy. So basically we need to take the sum of these forces and it will be equal to Rx. And if we take the summation of all these component, it will be equal to Ry. Right? So what is our Rx? Rx is 389.7 equals, and the summation of force in the x direction. So basically F1 sine phi plus 200 plus 100, right? So this is equation 1 which you get from Rx equals summation of Fx. Then when we use this expression, Ry is 225 and this is F1 cos phi plus 240 and this is equation 2. So you can see you have two equation 1 and equation 2, and you have two unknown. The first unknown is F1 and the second unknown is phi. So you have two equation 2 unknown. You can solve these two equation together to calculate these two unknowns. So let's say if I write my equation 2 as 225 minus 240, F1 and I put this expression in equation 1. So F1 is 225 minus 240 divided by cos phi sin phi plus 200 plus 100 is 300. So you can see now you just need to solve for phi, right? So it is 389.7 minus 300 equals, this is minus 15 by cos phi sin phi. So it will be minus 15 tan phi. So it is 89.7 divided by 15 tan phi, or when you solve this you will have tan phi equals 5.98. So when you solve for the phi you will have tan inverse 5.98. So phi will be around 10.9 degrees Celsius. And when you substitute this value of phi in any of this equation, equation 1, equation 2, or even this equation, let's say it's 3, in any of this equation you just substitute it. Let's say I choose to substitute in equation 2. So my equation 2 is 2 to 5 equals f1 cos phi, phi is 10.9 plus 240. So now the only unknown is f1. So it's 225 minus 240 f cos 10.9. So when you solve this, you will get f equals 474, approximately equal to 474 Newton, right? So little involved with mathematics, but the concept remain the same. So in this question, we have given three forces F1, F2, F3, and we have given the magnitude of resultant force R, which is along U axis, and we have been asked to calculate F1 and its angle from the vertical axis. So we have used this equation, and to use this equation we need to calculate all the sorry, all the component of uh, force in the x as well as in the y direction, and we did that. We calculate f1 component of f1, f2, f3 in the x direction, and then we calculate the component of resultant force, and we repeat this exercise uh, to calculate the force in the y direction, and we use this expression to get the unknown here. So any doubt in this problem? So even though it is little involved in mathematics, you can see the concept is pretty much the same that we have been using. So let's move to the next problem, and we will be using the same concept in the next problem as well. So here we need to determine the magnitude of force Fa and its direction theta, so that the resultant force is directed along the positive x-axis and has a magnitude of 1250 Newton. So it's pretty much the same problem, and it has been given that the resultant force is actually in the positive x direction and it has the magnitude of 1250 Newton. So it is less involved in mathematics because the whole resultant force is in the x direction, which means my Rx will be equal to 1250 Newton and my Ry equals to 0 Newton. So we don't need to consider the y component of the resultant force. So again, we will be using the similar concept that My resultant force in the x direction is just the summation of all the forces in the x direction, and my resultant force in the y direction is just the summation of all the forces in the y direction. When you again use this concept, you will already notice that we need to solve these two equations. Now Ry is 0, so it will be 0 equals summation of all the forces in the y direction, whereas Rx is 1250, which is equal to summation of forces in x direction. And we have given only two forces here, Fa and Fb, and we have given the angle theta and 30 degrees, so it's become even more uh, easy comparatively to the last question. So your Fa, you already know how to calculate the x component of Fa, which is f cos theta, because this is your Fay, sorry, it will be sine theta, and this will be your Fax. So Fax will be Fa sine theta, and Fay will be Fa cos theta, because the theta is from the vertical axis. And in all of this problem, you have noticed that it is the first step is to always define the Cartesian coordinate system in order to uh, measure the direction of these forces. So Fay is equals to Fa cos theta. Similarly, for Fb, you can see the angle is defined from the horizontal axis. So my uh, horizontal component of Fb will be Fb cos 30, and the vertical component of B will be Fb sin 30. Hello, hello, any doubt? Hello, any doubt? Banala Surya. Okay. So my Fbx, so now having defined all the components of force Fa and Fb, we can use this equation which come from the resultant equation, that is equal to summation of forces in their own direction. So if I consider this as equation 1 and this as equation 2, then 0 equals summation of force Fy. This is my equation 1. So if I consider all the forces in the y direction, which is Fay plus Fby, right? So Fay is in the positive y axis. You can already notice this. But judging from the direction of Fb, which is in positive x axis and negative y axis, because going downward, the direction of force is going right, and at the same time it's going downward. So this is the direction of this force, downward and right side, which basically means it's going towards positive x-axis and negative y-axis. So this force is actually a negative, minus Fb sine 30. So it will be Fa cos theta minus Fb sine theta. And right, so this is our equation 3, or we can even simplify this equation further. So this become Fa cos theta minus Fb by 2. So this is my equation 3. Sorry, my Fb is 800, right? So it is 800 by 2, so it will become 400. So this can be written as Fa cos theta equals 400, right? So you can see there are two unknown. There Fa is there, which is an unknown quantity, and theta is there, which is again an unknown quantity. Hello? Yeah, hello. Yeah, you have doubt. Can you see my screen? Is it got stuck? Okay, just a second. Okay, let me rejoin. So now can you able to see the screen? Okay, sorry for the interruption. So yeah, I was saying that if we use the equation 1 here, which is the summation of all the force components in the y direction equates to 0, you can write Fay plus Fby, and Fby is in the negative y direction. Sorry. So it will be Fa cos theta minus Fb sin theta. Then on simplification, Fa cos theta, Fb sin theta is basically 800 and sin 30 will be half. So 800 by 2, which is basically minus 400. So you will actually arrive to this equation Fa cos theta equals 400. Now in this equation, two quantities which are unknown, and they are Fa and theta, and you have one equation, two unknown. So we need one more equation to solve. So the one more equation we will get from this equation 2, which is 1250 equals summation of forces in the x direction. So 1250 will be equal to summation of all the forces in the x direction. So basically summation of Fax plus Fbx. So Fax is Fa sin theta and Fbx is Fb cos theta, and you can see from this figure both are in the positive x direction. So it is Fa sin theta plus Fb cos 30, right? So Fb is 800. So basically 1250 minus 800 cos 30 Fa sin theta. So it will be Fa sin, sorry, theta equals 557.179. Right? So now you have another two equations. 4, 5. So basically you can divide equation 5 with respect to 4, right? Because when you do that, you can actually able to remove Fa, right? So basically if you divide this equation by Fa cos theta equals 400, then Fa cancel and sin theta cos theta will be tan theta, and it is equal to 557.179 divided by 400. So in this way you can actually calculate theta. It will come out to be 54.3. Then you can substitute theta in any of this equation, 4, 5, or even 1 or 2. So when you do that, you will have, let's say I substitute in equation 5, so it will be Fa sin 54.3 equals 557.179. So my Fa will be so Fa will come out to be around 687 Newton. So you can see the concept was similar and even the step was similar. It is just less complicated because instead of 3 we were given only 2 forces. So it's similar to the previous problem here where we have given two forces Fa and Fb. We have given the direction of resultant force and its magnitude, and we have been asked to calculate force Fa and the direction theta. So we use the same concept because until now we have only limited number of concept, and if the problem is related to the if the problem contained different forces in different direction, then without a doubt we need to use this expression, because the resultant force then can be given by the summation of force in their own direction. For example, Rx will be the summation of Fx and Ry will be the summation of all forces in the y direction. So using this concept, again we can able to calculate the unknown force and angle theta. So any doubt? Then we can move to the next problem. So in this problem, determine the magnitude and angle measured counterclockwise from the positive y-axis of the resultant force acting on the bracket if Fb equals 600 Newton and theta equals 20. So it's a pretty straightforward. So until now we have been calculating one component of forces, or the one part of the external forces, here Fa in the previous problem, and in question 2 it was F1. But now in this question we have given all external forces Fa and Fb, and we just need to calculate the resultant force and its magnitude, right? So we have given Fa, which is 700 Newton, we have given Fb, which is 600 Newton, and we just need to calculate the magnitude and angle where the resultant is acting. So again use the same fact that Rx is summation of Fx and Ry is the summation of Fy, and we need to calculate the magnitude of the resultant force, which is equal to Rx square plus Ry square. Now in order to calculate this magnitude of the resultant force, we need to calculate Rx and Ry first, and that can be calculated by summing all the forces in the x and y direction. So Rx will be Fax plus Fbx. And what is Fax? You can easily see from this figure that the angle is measured from the vertical axis, and it's in the positive x-axis because its direction is in the right side. So it's Fa sine 30. So it's 700 by 2, which is 350 Newton. And my Fay will be Fa cos 30, which is 606.2 Newton, right? And you can also define the component of force Fb. So the angle it is measuring with the horizontal axis, and theta is given 20 and Fb is given as 600 Newton. And you can see Fbx is in the minus x direction because it is the direction of Fb is towards the left, which means towards the minus x axis. So it will be minus Fb cos 20, Fb is 600, so it is 563.8 Newton, and Fby will be Fb sine 20. So it will come out to be 205.212 Newton, right? So we have calculated the x and y components of Fa and Fb. So it will be, so Fax will be 350 and Fbx is minus 563. 0.8. So my Rx will be minus 263.8 Newton. And similarly, I can calculate Ry, which is Fay plus Fby. So Fay is 606.2 and Fby is 205.2. So it will come out to be 811.4 Newton. This is my Ry. So we have calculated Rx and Ry. So the magnitude of the resultant vector will be Rx square plus Ry square. So it will be 263.8 square plus 811.4 square.
Hello.
Hello.
Sir, RX is 213.8, sir.
Okay. So my FAX is 350 and my FBX, just a second. Yeah. So yes, this will be 213.8. So it will be 213.8 here. Then when we do squaring, it will be so when you do this exercise, you will get 839 Newton. So this is the magnitude of the resultant force, and to determine the angle at which it will acting, angle phi will be given by tan inverse Ry by Rx. So it will be tan inverse Ry is 811.4 and Rx is 213.8. So it become 811.4, 213.8, 3.795, and it become 14.8. So this is the phi, and this is the magnitude of uh, the resultant vector, which is 839 Newton. So it is pretty straightforward problem, because first we calculated all the component of force in x and y direction, and then we directly substitute in this equation to calculate Rx and Ry, and then we use this expression to calculate the magnitude. So any doubt in this question? If not, then we can move to the next concept. So until now we actually looked two things. The first thing is to calculate the sorry to calculate the component of resultant force, which is equal to the summation of forces in the respective direction, and then to calculate the magnitude of the resultant force, which can be given by this expression, and the directional angle can be given by tan inverse Ry by Rx. So from the Newton's law, you have been known that if we apply the force on the body, it actually start moving with some acceleration. Or if the body is already moving, uh, and if we apply forces, it actually pertains some kind of an acceleration. But without any force, there will be no acceleration. The body can move without the force if it is already moving. So it will remain in the motion, but it cannot change the direction, or it cannot change the magnitude of speed, because there is no change of momentum, and since there is no force, there is no change in the motion of the direction of motion of the body. So basically what I'm saying, that when you apply the forces, your body can translate in a certain direction, but force can also make body uh, ro- moving in a rotational direction. So basically if you apply the force, it can also rotate, and that can be possible by the movement, which is basically force multiplied by perpendicular distance. So this is the scalar expression of the moment. In the vector form, the moment can be defined by position vector cross product with the force. So let's say you have a force which is acting in some direction, and let's say you need to calculate the moment above this point O, and the perpendicular distances from this point is t, then the moment due to this force F is actually Fd about point O. So the moment about point O will be given by force multiplied by perpendicular distance. So basically you need two things to define the moment, or to exert the non-zero moment. First, the force magnitude should be non-zero, then the perpendicular distance should be non-zero. In the vector form, you can actually define, so you have a force here, and this is your position vector, this is your force, and this is the perpendicular distance. And at point O, you can define the moment as r cross f, which can also be defined as r fr sine alpha. This is r alpha, and r sine alpha will be d. So you can eventually arrive at the same scalar equation fd. So two things you need to calculate the moment: first force, and then a perpendicular distance. Then there is a Varignon theorem which says that moment, sorry, so it says that moment of any resultant force at a point is equal to sum of moment of components of force about same point. So basically if you have a point and there are multiple forces which are acting here, then if you want to calculate the moment at some other point, let's say here, you need to calculate the moment at about O, then you can actually calculate the moment of these individual forces, and then sum all of this movement together to actually define the moment at point O. So this is a Varignon theorem which says that the moment at point O is actually the summation of movement from P about O plus movement of force R about O plus movement of force Q plus moment of force S. So this is the Varignon theorem that we will be often using in the question. So just to note that in order to calculate the movement, we always need a perpendicular distance. So whenever we want to calculate the movement, we just need to define the perpendicular distance from that force. So that that will be clear by solving this question. So in this question, we have a force of 600 Newton, which is applying uh, from the 40 degree in the horizontal direction, and there is a column. The vertical length is 4 meter and the horizontal length is 2 meter, and basically we need to calculate the movement about point O, right? So what we have learned that we need a force, magnitude of force, and we need a perpendicular distance to calculate the movement. So we can see in this question that we can actually use multiple ways to actually calculate the movement. So the first is a very straightforward way. We have given the 600 Newton force here, right? So we have already given force, and now we need to identify the perpendicular distance d. So what will be the perpendicular distance uh, of this force from point O? So it will be this. So this will be the perpendicular distance here. So if we can able to calculate d, we can directly apply the expression of movement. We already know about the force, we calculate d, and we will directly get the magnitude of the movement of force 600 about point O. So now here our objective is to calculate d, perpendicular distance. So for that, so this is 40 degree. So from law of angle, this is also a 40. This is 90. So this angle will become 90 minus 40, which is 50. So this is 50, so this will become 40. This is 90, and this will be 50, right? So this distance, basically this distance will be 4 cos 40, and this distance will be, so this is 2 meter, right? So I know this distance, so I can actually calculate this distance, which is 2 sine 40. So my d will be 4 cos 40 plus 2 sine 40. So it will become 4 3.06 plus 1.285. So it will become 4.35 meter. So this is my d. So now I can calculate the movement, which is 600 Newton multiplied by 4.35 meter. Sorry. So my moment will be 2610 Newton meter, right? So as we discussed here, in order to calculate the moment, we need a perpendicular distance and force F. So we calculate the perpendicular distance from the trigonometry, which is 4.35 meter, which is actually 4 cos 40 and 2 sin 40. Once we get the perpendicular distance, which is this, of this force, we can calculate the moment easily. Now there is another method you can actually follow. If you don't need to use rigorously the trigonometry relation, is you already given a force 600 Newton from the angle 40, so you create the component of force. So let's say you define the component fx and fy of this force. So now you can use Varignon theorem, which says that the summation of moment is come from summation of moment from each force mx plus my. So what we are doing, we need to calculate the moment due to this force, and we need to calculate the moment due to this force, which is mx, and here it is my. And from the Varignon theorem, it will be just the summation of moments. So first you need to define the perpendicular distance. So earlier we defined this ever perpendicular distance for this force 600 Newton. But now we are not considering this 600 Newton force. We are considering component of this 600 Newton force. So from the visualization itself, you can define the perpendicular distance. So for fx, what will be the perpendicular distance? So for fx, this will be my perpendicular distance 4 meter for fx, right? And for fy, if this is my fy, then this will be my perpendicular distance 2 meter. So you can see, if you define the component of force, then you don't need complicated evaluation, trigonometric evaluation to define the perpendicular distance, because it is easily from the visualization itself you can easily calculate the perpendicular distance 4 meter for fx and 2 meter for fy. So now first you need to calculate fx and fy. So you have already given the angle 40 from the horizontal axis. So you can actually calculate fx, which is 600 cos 40. So it will come around 460 Newton, and fy will be 600 sine 40. So fy will be around 385 Newton. So fx is 460 and fy is 385. Now you can actually uh, calculate the movement, because it has both fx and fy have perpendicular distance, finite non-zero perpendicular distance, which mean the movement due to fx and fy are non-zero. So your mx will be fx dx. So mx is fx is 460, dx is 4 meter, because if my this is my fx, then this will be my perpendicular distance, which is 4 meter here. So it will be 1840 Newton meter, and your my will be fy multiplied by perpendicular distance, which is dy. So your fy is 385 multiplied by 2, which is 770. So from the Varignon's theorem, the summation of movement at about point O will be, the movement at point O will be the summation of all the movement from all these forces. So basically it's MO equals MX plus MY. So you can see 1840 plus 770, so it will come out to be 2610 Newton meter. So again we actually arrive to the same value 2610. here. In the first method, we actually directly define the perpendicular distance of 600 Newton force, and we arrived at 2610 Newton meter. But we found that trigonometry, if we use the concept of trigonometry, it is actually much involved. The mathematics is quite involved. So what we did, we defined the force component of force 600 Newton, Fx and Fy. We saw that it is very easy to define the perpendicular distance of Fx and Fy. So we did that, which is 2 meter and 4 meter respectively. Then we calculate the component of force Fx and Fy. Once we got Fx and Fy, we calculate movement due to Fx and movement due to Fy, and using Varignon's theorem, we actually arrive at the same result. Now there is one more method you can actually use to calculate the movement. So in all of this method, we are using the fact that you need non-zero perpendicular distance. So earlier in this lecture, we actually talk about that you can actually slide the force along the line of action. So this is your line of action for this force. You can actually define force here also, 600 Newton, or you can define force here also, which is 600 Newton. So basically you can slide the force along the line of action. The response will be the same that we have discussed earlier in the class. So let's say if I define force here, 600 Newton, and now I calculate the component of force Fx and Fy, right? So now what will be the perpendicular distance of Fx and what will be the perpendicular distance of Fy from here? So from Fy, the perpendicular distance I can see from O is this. This is my perpendicular distance of Fy. So I know dy. So I can define dy. It's a non-zero. But there is no perpendicular distance for Fx, which means the movement due to force Fx is zero now. Now it is zero because dx is zero. There is no perpendicular distance from point O to Fx. So dx is zero, which means mx is zero. So now I need to calculate my Fy dy and check if I get the same result 2610 that we have obtained from last two method. So now I need to calculate this distance, which is dy here. So again I can use the law of trigonometry. So this is my triangle. So this I know, which is 2 meter, right? This is my 2 meter, and I know this side also, 4 meter. I know this side and I need to calculate this side. So I can use cot. So let's say this is my angle. This is angle 40. So here I can use, let's say this is my x1. So my x1 will be 4 cot 40. So this perpendicular distance will be 2 plus x1 dy. So dy is 2 plus x1. So my dy is 2 plus 4 cot 40. So let me calculate dy first. So it is 6.77 meter. So you calculated dy 6.77, then your my is Fy multiplied by dy. Your Fy, you have calculated Fy as 386 Newton. 380, sorry, 385 multiply by 6.77, and when you multiply, you will arrive at the same value 2610, because mx is 0. So basically, if you use the Varignon theorem, you will get mo equals to my, right? So just to recap, we have given this force 600 Newton, and we have to calculate the movement from this force about point O. And in this question, we actually use three methods to calculate the movement. In first method, now we know that in order to calculate the movement, we need a perpendicular distance and non-zero force. So the force is already non-zero and we need perpendicular distance. So for the first method, we directly draw the perpendicular distance, which is d, for this force 600 Newton. From trigonometry, we actually calculate d to arrive 2610 Newton meter to calculate the movement, which is 2610. Then in second method, what we did, we actually split this force 600 Newton to its component Fx and Fy. We found that determining the perpendicular distance for Fx and Fy is pretty straightforward. So it was actually 4 meter and 2 meter. Then we calculate Fx and Fy. Then we calculate movement due to Fx, which is mx, and movement due to Fy, which is Fy. And using Varignon theorem, we actually calculate the movement at point O, which is basically a summation of movement from all the forces. Here in this case, it is Fx and Fy. Then we use another concept, that this force, so every force has its own line of action. So this force basically you can shift to either here, 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 or even here. We shift to here, and then we repeat the exercise. We calculate Fx and Fy. We determine dx, perpendicular distance to Fx. We determine dy, which is perpendicular distance to Fy. We found dx is 0, and that again we determine mx and my. We found mx was 0 in this case, and we found that my is actually the moment we required. So again, this come out to be 2610. So from all these three methods, we actually arrive at the same value of the movement. So any doubt in this question? So in all of these three methods, we actually use the fact that we need to define the perpendicular distance. If no doubt, then we can move to the next problem. So until now we have talked about the movements. We have talked about the magnitude of the movement. We have not discussed about the direction of the movement, then how to consider the direction. So in this problem, yes, yeah, hello, can, so any doubt? Anybody has doubt? Can just, Shri Krishna, think you have raised the hand.
Nothing, sir. It was clicked.
Oh, okay, no problem. So let's move to the next problem. So until now we have been involved in finding the magnitude of the movements, but in most of the problem we actually need to determine the sign or the direction of the movement. So in this problem, since we have given the multiple forces in a random direction, here determining the direction of the movement is very important, because when we use the Varignon theorem, which says that the movement at point O, let's say random point O, is the summation of movement from all the forces. This summation contains the movement in both a direction. It contains positive movement, it may contain the negative movements. So you need to ensure the direction of movement first. So let's say in this problem, I am defining the clockwise direction of movement as positive and anti-clockwise movement as a negative direction. Now in this question we have given three forces, F1, F2 and F3, and we need to find the movement at point A, right? So there are two things to note. First thing is that we have discussed in the previous question to define the perpendicular distance, which is t. The second thing is to determine the direction of the movement about point A, because we need to calculate the movement about point A. So the perpendicular, since we have a non-zero forces here, we have three non-zero forces, the perpendicular distance will determine if any of these forces have a non-zero movement about point A. So for example, the force F1 will not have any movement about point A, because there is no perpendicular or any kind of distance from point A to F1, because force F1 is exerting exactly on point A. So there is no perpendicular distance. So this force F1 is not creating any movement. There is no movement of force F1 about point A. So basically your M1 is 0, right? Then let's say we define here F3y, and here we define F3x. Here we define F2x and F2y. So now we need to define the perpendicular distance of F3y, F3x and F2x and F2y. So for F3x there is no perpendicular distance, because the perpendicular distance should be in this direction, and you can see from point A there is no perpendicular distance for F3x, which means F3x will not create any movement about point A. It can create a movement at any other point, like at point B or here, but about point A it is not creating any movement. Similarly, the perpendicular distance of F3y to point A will be this. This is the perpendicular distance, which is 8 meter. So this force is creating a movement about point A. The F2x has the perpendicular distance, which is this, about point A. So F2x is again creating a movement about point A, and F2y, since it doesn't have any perpendicular distance from point A, F2y is not involved uh, in creating movement about point A. So only forces which are creating the movement are F3y and F2x. These two are the only forces which are creating movement about point A. Now we need to define the direction. So we said that the, the clockwise movement is positive and anti-clockwise movement we assume is negative. You can also choose otherwise. You can choose clockwise as negative and anti-clockwise as positive. It is actually based on your choice. In this question we follow this notation where the clockwise is positive. So you can see the direction of F3y. So about point O, it has to rotate like this, about point O, right? So the direction is actually anti-clockwise. So the movement due to force F3y will be negative. Similarly, F2x is in the right direction, from left to right direction, and in order to rotate for point O, it has to rotate like this. So again, it has to follow the anti-clockwise rotation. So F2x, the movement due to F2x is again negative. So in order to determine the movement due to F2x and F3y, first we need to calculate the value of F2x and F2y. So F2x is 80 cos 45 which is 56.56 Newton, and F3y is F3, which is 40 sine 30, which is 20 Newton. So F3y is 20 Newton and F2x is 56.56 Newton. So my movement due to F2x is F2x d2x. So F2x is 56.56, and this is negative because we have just discussed both are in anti-clockwise direction. So both movement due to both forces are negative. So it's minus 56.56 multiplied by, so this is my perpendicular distance 2 meter to basically minus 113.137 Newton meter. Then my movement due to force F3y is minus F3y d3y minus 20, and the perpendicular distance of F3y to A is this 8 meters, right, which is minus 160 Newton meter. So my movement at point A is the summation of all the movement due to all of this force F3y F2x. So it will be m2x plus m3y. So it's minus 113.137 minus 160. So it will be minus 273 Newton meter, or it's 273 Newton meter in counterclockwise direction. So my resultant movement at point A is 273 Newton meter in counterclockwise direction. So any doubt? So if no doubt, then we can stop here. So we will be solving few more questions from movements, and then we will be solving some question from equilibrium. We will first revise the what is mean by the equilibrium, and then we will begin solving question on trusses. So next week we will be solving. We will be start by solving question from movement, go to equilibrium, and then we will extend the equilibrium concept to the trusses. So if you have any doubt from the today's class, you can just ask. We will meet next week, same time. You can also give any feedback on questions, that whether you find questions are pretty easy or pretty hard accordingly. So are the level of questions are fine, should be more easy or should be more hard, like that. or any kind of feedback based on today class? Okay, then we will meet next week. Thank you.
Hello?
Hello.
Please, when will the tutorials be uploaded?
Yeah, I will upload this tutorial on weekend. I will upload the video on YouTube and this PDF.
All right. Thank you very much.